Right, when you're working with questions to do with products of prime numbers, the key thing to remember is that you need to repeatedly divide the given number by prime numbers 2, 3, 5, 7, etc. until you can no longer divide what you have by any other prime numbers. So basically that number that you're left with is also prime. So the easiest thing to start with is to look at the number and ask yourself if it's even. If the answer is yes, if it is even, then you can divide by 2. So you can see here we're starting with the number 126 and we're dividing it by 2, and the way that we tend to write this is by branches. So if we're dividing that by 2, then we get 63. So now we're looking at this number. Can we divide that number by 2? The answer to that is no. So then you're thinking, well, what other prime numbers can you divide 63 by? The next one to try after 2 would be 3. Does 3 go into that? Well, 3 goes into 6 twice and into 3 once. So yes, you can divide that by 3. And when you divide it by 3, as I said, you get 21. 21 isn't prime. It isn't even, so 2 doesn't go into it. But again, I know that 3 goes into that 7 times. 7 is a prime number, so I can then stop my repeated division because all of these are prime numbers. So that means that 126 is the same as multiplying 2 by 3 by 3 by 7. But because the question asks you to write down index notation, that means that you write it as 2 and then 3 times 3 you can write as 3 squared. 2 on its own is the same as 2 to the power of 1 and 7 to the power of 1. So in index notation you would write 2 to the power of 1 times 3 squared times 7 to the power of 1. If you didn't write those ones there, you would still get the answer correct, but by getting in the habit of putting those ones there, it'll help any additional questions, as you'll see later with these, make it more straightforward for you to answer. So question 2. Explain how you know that 24 is not a square number. The first thing you do is you write that again as a product of its primes. So we start with 24, it's even, so I know that 2 goes into it, and I know that 2 goes into it 12 times. 12 is even, so I know that 2 goes into it 6 times. 6 is even, 2 goes into it 3 times, and there you can see I've got all prime numbers, so I can stop. So I know that 24 is the same as 2 times 2 times 2, which is 2 cubed, times 3 to the power of 1. Now, the fact that you need to learn to do with products of primes and square numbers is that if this was a square number, then all the powers that we have when we write it as a product of primes would be even. So that number there would be a 2, a 4, a 6. That number there would be a 2, or 4, or 6. In which case, that would be a square number. Okay, so it's not a square number because the powers are not all even. And that's the fact that you need to know. Part B is the same as the first question. We start off with 112 and it's even, so we divide by 2. When we divide that by 2, we get 56. 56 is even, so I can divide it by 2. When I divide it by 2, I get 28. 28 is even, I can divide by 2. I get 14, which is even. I can divide by 2 and get 7. not only is 7 odd, but it's also a prime number, so I can stop. So 112 would be 2 times 2 times 2 times 2, which is 2 to the power of 4, multiplied by 7 to the power of 1. And that's as far as you need to go with that. With question 3, you're starting with 525, and another key one to look at is if you have a number that ends in a 5 or a 0, 5 will divide into it. So the first thing you're going to divide that by is 5. 5 goes into 5 once, and then into 2 0 times, and into 5 once. So that's going to be 101. Then we're looking for a number that will go into 101, and again it's not even, so I would try 3 next. It's not 3. What is it? 105. Of course it is. It's 105, which is ending in a 5, so we can divide that by 5, and that goes in 21 times. 21 isn't a prime number. We know that 7 goes into it 3 times. Now I can stop. All of those are prime numbers, so I can write 525 as 5 times 5 times 7 times 3. We tend to write it in order of size of the digits, so we would go 3 times 5, which is 5 squared, times 7 to the power of 1. Question 4, 792 as a product of primes. It's even, so we know that 2 goes into it. 2 is going to go into that. It's likely to be on a paper 2 here with a number like that. So you can get a calculator. 792 divided by 2, 396. It's even, so we can divide by 2. Get 198. It's even. We can divide by 2, which is 99, which isn't even, but 3 is going to go into that 33 times. 3 is going to go into that 11 times. Stop there, they're all prime numbers. So therefore 792 is going to be 2 times 2 times 2, which is 2 to the power of 3, times 3 times 3, 3 squared, times 11, and that only appears once, so to the power of 1. Why is 18 not a perfect square? Well, break it down into its product of prime numbers first off, and then let's have a look at what its powers are. So 18, 2 goes into it 9 times, 3 goes into that 3 times. Stop there. 18 is 2 to the power of 1 times 3 squared. So it's not a perfect square because all the powers aren't even. If that had been 2 to the power of 2 or 2 to the power of 4, then both the powers would have been even and it would have been a square number. And the final two questions that we've got on this. See how similar these are now to the previous ones. We're starting with 112. It's even, we divide by 2. When we divide it by 2, we get 56. It's even, divide by 2. When we divide it by 2, we get 28. It's even, divide by 2, we get 14. it's even, divide by 2, we get 7. Then we can stop. They're all prime numbers. So 112 is 2 times 2 times 2 times 2, which is 2 to the power of 4, times 7 to the power of 1. How do we know 32 is not square? Break it into its products of primes, first of all. So we start at 32, it's even, we divide by 2, gives us 16. It's even, we divide by 2, gives us 8. It's even, we divide by 2, gives us 4. It's even, we divide by 2, it gives us 2. We stop there because those are all even. So 32 is 2 times 2 times 2 times 2 times 2, which is 2 multiplied by itself 5 times, 2 to the power of 5. That's not even, it's not a square number. So it's not square as the power is odd. And the final question, 1323, well, this would be on a calculator allowed paper again. Certainly 2 is not going to go into it, so I would try 3 next. 1323 divided by 3, yes, that goes in 441 times. Again, it's not even, so I'd try dividing it by 3, and it does go in 147 times. Not even, try 3. Goes in 49 times, and I know that 49 is 7 times 7. So 1323 is 3 times 3 times 3, which is 3 cubed, times 7 squared. And in the final part of that, write down the least whole number by which 1323 should be multiplied to make the result a perfect square. Well, we know it's not a perfect square because it's to the power of 3, which is odd. So in order to make that a perfect square, I would need to make that 3 even by multiplying by another 3. If I multiply that by another 3, I would get 3 to the power of 4 times 7 squared. Both of the powers would be even, so therefore it would be a square number. So the least whole number would be 3. If I multiply that by 3, I would get a square number. And you can check that on your calculator just to make sure that it's correct. So if you've got 1323 times 3, I get 3,969. And if I take the square root of that, I get 63, which is a whole number, therefore that was a square number. And that's products of primes.